All right, so let's see. This call is being recorded. I'll get this up on uh, YouTube as soon as I can. So let's see. I guess we'll go ahead and go right into it. All right. Well, this is Aaron Murakami with emediapress.com, and today is November 15th, 2025. It's 12 o'clock Pacific Standard Time, and I have Eric Dollard on the call, and we have a few others from the crew. We got Haka Says, who is helping us down in Tonopah with some of the projects. See Adrian Marsh on here. It's been a little while. He's in the
Indeed, it's been too
UK
long
and
now.
too long, yeah.
Too long.
And so over the last several weeks, I've been putting out some videos showcasing some of the projects going on at EPD Laboratories, Inc. down in Tonopah, Nevada. This would include some of the ground radio reception experiments, showing that hooking Eric's car antenna to a ground system that immediately every channel on his entire AM radio came through loud and clear. And when I did the same thing with my 2007 Toyota Tundra, pretty much all it picked up was power line noise. And then we had some videos on the Earth Signal project, which there's the long lines which terminate at the shack, and then those signals are being streamed online. Those are available at epdlabs.org, and there's a seismic streaming link, something like that. And if you go on there, you can hear these signals, kind of cracks and pops that are related to lightning strikes around the world. And these are related to some precursors of seismic activity when you start to hear these kind of build up. We show some of that. There's some pole work on these lines, which is very difficult work that Justin and Connor were kind of focusing on. We have some of that video and putting up one of the poles right next to the shack. And then, that gives an idea of how hard a lot of that work is, not just bench work and working on circuits and, the stuff inside the shack, but the actual lot of physical labor up there with people's feet going dead in these work boots, you know, 20 feet up in the air on the ladders, not an easy thing to do. There's also there's a video on the telluric beacon. We can go over some of that. There's also an audio amplifier project, which Eric has been working on this for quite a while now. For years, that's been a working amplifier on the bench, which is intended to amplify some of the earth signals. And then there's going to be a commercial audio amplifier available at some point that we started to work on during that episode, which will be a simplified version of it. And there's a video on that kind of showing how that's coming together. And then I think there's kind of a basic summary overview kind of video. So with this call, normally what I've done is release these live calls all in one, as one big video. And so instead of making this one too long, what I want to do is kind of focus on we can kind of go over and kind of review the videos in segments and then take some questions for that particular topic and then move on to the next one. That way I can crop this video where we're talking specifically about the earth signals, for example, with some of the Q&A from whoever's on the call. Feel free to ask any questions relevant to that particular topic. And that way I can have a video go out that's just on that particular topic. And then, I'll cut this video down like that for the rest of the topics as well as I put them out, incrementally. So just a couple quick announcements. A lot of these video presentations, if you go to, I'll go ahead and do a screen share real quick. So on emediapress.com/blog, this is sequentially where I've been posting the blog posts that kind of have a basic kind of overview and then a video embedded. Um, or you can go to youtube.com, and if you just type my name, Aaron Murakami, you'll see all the videos. So on this page, Aaron Murakami 13 is the username for my YouTube channel, And if you just click on videos here, you can see all of them that have been posted sequentially. And the ones from the Tonopah episode, this kind of goes back to roughly about a month ago. So over the past month, there's 8, 9, 10, 11, 12. There's 12 videos. This open wire demo goes back to about 2017 or something. But starting at the ground reception video, these are all related to all the work that we did down in Tonopah with, let's see, Yari Karvanen. There's a little thumbnail right here. He helped with a lot of the storage locker organization, the so-called glom locker. Haka says helped with the Earth signal and the telluric beacon. Justin focused a lot of his work on doing a lot of the actual line and pole work. Then, of course, Eric has taken part in pretty much all of it. Connor, he helped a lot with the line work and a lot of the stuff up at the shack. And then myself, besides just trying to document everything, my focus was mostly doing a lot of the metal fabrication work for the panels for the audio amplifier. And so let's see, EPD Laboratories, Inc. is a 501c3 nonprofit organization that survives solely on your donations. So if you go to ericpdollar.com and click on donate, this will take you to a page where it has a PayPal donate link. You can do a one-time donation, or you can click an option to do recurring donations. Let this pop up for a second. You can just click that box, do $5 a month, $20 a month, $50 a month. That pays all the overhead, tax, insurance on the building, parts, materials, for these projects. Some of it helps to cover some of the travel and lodging and food expenses for some of us going down to work on some of these projects. Or you can send a check or money order to this address here in Spokane, and I just sign those checks and then send them down to the bank in Tonopah, and that is what funds EPD Laboratories, Inc., but also a portion of the proceeds from all the sales of Eric's videos and books published on emediapress.com also goes to EPD Labs to help fund the projects. And so is there anything in particular you want to start with, Eric, or just start with the first topic and go from there?
Well, yeah, maybe I was thinking, in terms of the number of views and comments,
Okay.
and the highest one was Telluric Test Platform, and then the thing with the car radios was the next one. So let's start with the car radio one.
Car radio. Okay,
Yeah.
so that's the ground reception video that anybody can watch on the YouTube channel, or you can go to emediapress.com, click on blog, and then scroll down roughly about a month ago when the ground radio reception one came out. And so do you want to kind of give some people will have seen that video and some haven't seen it, I'm sure, but do you want to kind of give a synopsis of what the ground radio reception experiment was about?
Yeah, okay. I don't know if you can get one shot of me connecting the wires to the car out of those slides.
Okay, here, I'll just pause it right there. So Eric's pointing to the antenna here, and then there's some wires that he's literally connecting to the body of the car or wrapping around your antenna.
Yeah, so basically there we go. That's the one I want. At least I'm pointing at where all my connecting points are on my car, at least on the port side of the car. This is at one end of the 4,800-foot pole pair aerial. There you go, it's a little better. This is the opposite end of where the shack connects. The shack, cable TV shack, is picking up the voice frequency part of the spectrum, but this end picks up the medium frequency, low frequency portions of the spectrum. So at any rate, I usually go out there daily, and it dawned on me to do an experiment in my idea that the AM radio, a real AM radio, which don't exist anymore, they don't make them, but a real AM radio in a real car is not picking up from that little aerial, because that thing doesn't have enough of a fraction of a wavelength to pick up any electromagnetism at all. It's just a capacitor. that actually the radio signal is being received out of the earth. So across the road there where the other stub poles are, there's a long line of ground rods and buried chemically treated underground electrodes into an aquifer zone that like an underground stream or something underneath the ground there, and which is a super ground. It's estimated to have a resistive impedance of somewhere around an ohm. There, you just have a picture of one of the terminals on it. There's the rocks and stuff. So at any rate, so I decided one day when I was out there, well, let's hook this thing to the ground system. And there you go. You keep missing the good shots. That's that one. There we go. That's the chemically treated buried electrode ground system. The ground rod ones terminate on the can on the pole on the other side of my car. So what I did is I have a jumper, clip lead jumper kit for connecting car batteries together. And I took the alligator clip and put it on the two ground wires that come out at the terminal, one chemical, the other one the ground rods, and put it on the big clip and connect it to the terminal on the fender of my car. And before I even touched it to the car body, it was already starting to pick up. And then when it made contact with the neutral terminal of the radio system on the car, then the AM radio just blasted to life without anything being connected to the antenna. And at that point, I was assured that this telluric propagation thing is totally valid. Then what I did next to balance it out is I capacitively coupled the aerial 4,800 foot pair of 10 gauge wires to about maybe 1 or 2 picofarads of capacitance to the elevated capacity on the car to couple to it. And then the AM radio virtually picked up every AM radio station within over 1,000 miles in every direction. At night, would probably pick up every radio station in the country. You wouldn't even be able to distinguish who's who. It'd just be a roar. So that balanced it out with the aerial and the ground connections symmetrical. And I'll point out what the AM radio has in the car, or at least in my car. It has a Tesla transformer in there because it has to use a coil with so many turns that the self-capacitance of the coil now represents a large part of the energy storage of the signal in the input to the car radio. And that's augmented by the aerial capacity that's away from the car body, kind of as the counter space reference point. And then the neutral of that coil connects to the chassis of the radio, which connects to the body of the car, and the coil is tuned by an iron powder slug that moves in and out of the coil to make the right amount of magnetism to match the dielectricity at the frequency you want to listen to. So it's a valid Tesla transformer. So basically, it's a little tiny Wardenclyffe inside of the AM radio, which the ground is the body of the car, and the elevated capacity is the little 18-inch piece of stainless steel rod that comes out of the fender of the car. Now, the impedance of this system is extremely high. It's like in the megohm range, so it's like sensitive to you moving around, and it's all the same characteristics as you would experience with the Tesla transformer. So then Aaron got the idea, well, let's try it on his vehicle. And that sounded interesting. And his vehicle refused to pick up AM radio stations, assisted or not, even though I would pick up 8 of them in my car completely unassisted all the way So Las Vegas, Reno, Los Angeles, Alturas, 500-mile range. But Aaron's radio wouldn't pick up anything. And moreover, even though we have 4,800 feet of wire, basically collinear, so to speak, or parallel to, I should say, the power line and the energy power line, my radio should just be roaring with interference, but it wasn't picking up any at all, other than the insulator crackling. But Aaron's radio in his vehicle picked up the power line hum like it was designed to. I mean, it had like ultimate fidelity. You could hear the difference between the odd and even harmonics as you tuned through it. And it was like its own little surreal musical instrument of power line noises. But it refused to pick up AM radio stations until reluctantly we finally got it to kind of pick up some stuff. But it shows you that my premise is modern equipment and digital equipment does not work. There's the proof. And there's the proof that the car body, not the so-called antenna, is what's receiving the signals. So the next step then is the telluric test platform. That's the transmitting side. The aerial out there on the right of way is the receiving side, and the telluric test platform is the transmitting side. So this eventually is supposed to be a two-way type of situation, at least an experimental version.
So do we want to see if anybody has any questions on this
Yeah, this would be the time
reception
to ask
thing?
questions.
But
Questions only related to this subject, nothing else.
yeah, just
Yeah.
the ground antenna business.
Yeah.
I mean, it was eye-opening for me because that shows that radio in that Tundra absolutely is not a real radio. It's like some digital thing that is looking for some voltage spike or something, how you explained it, and then it's amplifying, that particular frequency or something, but it's not picking it up like
It doesn't have the ability to pick up the longitudinal wave. It's all it is a potential sensor for the transverse component of electromagnetic wave, which doesn't exist out there except from the power line. That's why my radio is not picking up the power line, but that radio is, because I'm receiving longitudinal and you're receiving in some half-baked idea of transverse, which means that you're not receiving. So all of these things just continue to support Tesla's idea of this alternate mode of transmission as a reality. That was just what we did, was a striking demonstration of that.
Mm-hmm.
Irrefutable as far as I'm concerned. Of course, there'll be the snivets that will have to throw something in, but at any rate, they're compelled to.
Yeah, I could pick up maybe almost kind of faintly kind of hear stuff on 2, maybe 3 stations. But yeah, when you were scrolling through your dial, literally every single spot, there was stuff coming through loud and clear. So that tells me, even for safety, emergency, or whatever, you want to get a radio that actually has a coil in it.
Well, I'll tell you, when shit hits the fan, I'm going to have the only car working on the road. I'm not joking.
Well, I do have a 77 Datsun pickup with the real radio in it, but
oh, that'll work.
It is kind of a rust bucket, but it's for experimental use only.
That'll work. Nothing will stop that. I had one of those. It's my Guam vehicle. I carried tons over Mount Tamalpais with it.
Okay, so here's a question from AmitSys42. Can you elaborate on counter space reference point in the Tesla coil in your car radio? Which component of the Tesla coil was the counter space reference point?
The antenna coming out of the fender, which isn't an antenna, it's an aerial capacity. What it does is there's lines of force that emanate from that antenna that do not return to any physical object. They're free space. And that makes that antenna a reference point. And that point exists in counter space because that's the dimensions of capacitance is counter space. So the closer you bring the electrodes together in any kind of so-called electrostatic condenser, the tighter that space, the more dielectric energy it holds. So basically, the dimension of space is inverted. It's not in centimeters, it's per centimeters. And I gave it, for better or worse, I gave that the term counter space. Because space to the first power would be space, and then space to the -1 power would be counter space. So when I say counter space, that's what I mean. I'm not talking in centimeters, I'm talking in per centimeters. There's no other significance given other than that phrase was coined by Goethe and later picked up heavily by Rudolf Steiner and his followers. And even Steinmetz had an idea of it. But my use of the word counter space is as I just defined, no more than that.
Yeah, if you click on react, you can raise hand, and then I'll see that, and we can unmute you, and or you can unmute yourself.
Eric, I'd like to, can you speak a little bit about how the longitudinal mode can propagate in the Earth under such high frequencies? So the AM frequency is still very high for the longitudinal mode in the Earth. Can you speak to how that's possible?
Well, I can theorize, but I can't say that I know.
Sure, it's working for sure.
Well,
but
see,
I mean,
the thing here, I'm looking at this from an engineering standpoint. In that, that I was originally set on a mission by the executive branch of Radio Corporation of America in San Francisco regarding the Bolinas station. And that was to develop a new form of ship-to-shore transmission that would defeat the satellites before they defeated us. And I'm still heading in that direction, and this is still basically considered a maritime communications project. That's the route that I'm going. So that would be the medium frequency band, because those allocations, even though they're not really being used much anymore, they're still available. In fact, I think it might actually be quite possible because the ham bands have just become, they're worthless. Ham radio basically, can be made analogous to, going to the bathroom in a Greyhound station. I think you'd have to be an American and understand the meaning of that. It's not there anymore. It's just people playing with China toys and yes. So with what we're doing right now, okay, is laying the groundwork for the possibility of the FCC opening up another branch of experimental radio that doesn't involve any digital chatter or, yuck, 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 or whatever. It's strictly scientifically based, like ham radio was when it got started. And then people get licenses, they have to prove their proficiency and, and then sign the papers that say they're not going to break the law and open up a whole new, bring back the old time experimental radio where people, most of which are going to be older hams or, a lot of people that are hams, and where they'll be allocated. In fact, there is an FCC allocation now in the medium wave band, but it's like peewee power. But at any rate, to get to your question, it's not conductivity in the sense that conductivity is misunderstood. Notice how I did not say the way that conductivity is understood, but the way that conductivity is misunderstood.
But then it's a major step forward because, I mean, Tesla was working at, let's say, 45 kilohertz in telluric. But I mean, what you've demonstrated is that at let's say 1,000 kilohertz is basically moving in a longitudinal mode through the Earth. I mean, that's a very major step.
Well, it's giving the appearance of that. I mean, you have to remember, that there's pretty heavy dielectric flux around the so-called antenna that's going out into free space, but that's not electromagnetic. That doesn't radiate.
Indeed. But that would, you would expect that to happen because, it has to have its balance. It has to have its
Well,
counterpoise, so to
that's
speak.
that's the key. It's underground and overground.
Indeed. I agree very much. It's
I mean,
the two in
at
harmony.
least from a theoretical standpoint, that is a worthwhile theory. The other worthwhile theory is Tesla currents are also J.J. Thomson currents, which
Yes.
never discussed. And J.J. Thomson, he had a reason for, being poisonous when he made the statement of here's to the electron may be of no use to anybody. Because he was not looking for the electron. That was a step along the way. He was looking for the corpuscle of electricity, which he never really finished. He laid the groundwork for it. I finally finished from his book. I managed to put all the pieces together. It was hell. I almost threw the book over the side in the process, cursed him heavily for being such a physics jackass. But the thing is I actually managed to nail it down and come up with the dimensions of that corpuscle of electricity. And it has absolutely nothing to do with the electron. So J.J. Thomson, Heaviside, Steinmetz, Tesla, he never wrote any books or told anybody about anything, but nevertheless, he would be one that would be using this alternate current. And it's not conductivity, it flows through the mutual dielectric induction, which is the inverse of capacitance, in between the intermolecular dimensions, in between the atoms and molecules.
We could simply say it's displaced.
Yeah, but you got to watch out about displacement current because it's misunderstood or not understood, but claimed that displacement current generates a magnetic field that may or may not be.
I agree. I'm simply saying it's actually displaced.
Yeah, it's capacitor current. In other words, it relates to, the lines of force themselves, and it flows, coaxial with the lines of force.
Agreed. That's also my experience too.
So that's a possible theory. That would be how, you could get dielectric conduction through, like ionized gases, and because that's a similar type of situation.
Yes.
Everything is all heavily charged and there's loads of lines of force, pulling everything together and what have you. So it's going to be something like that.
Well, also, that also corresponds with the principle of Tesla's tube. So the vacuum tube is also potentially along those lines that you're speaking about.
Well, that's kind of another area, but it might be similar and it might not. But Tesla had always been thinking in terms of a single so-called conductor for conveying electrical power from one point to another.
For sure, agreed. But
they go, well, where's the return circuit? Well, there doesn't really have to be a return circuit.
Indeed.
The whole thing has gone into the intermolecular dimensions, and there's no magnetic field being produced.
Well, but this is the interesting thing, because if it's coherent, so when the electric and magnetic field is coherent, they are in effect acting as one. There is only one conductor when those two fields are coherent with each other.
Yeah, are you saying being coherent, or do you mean they're basically coaxial or one and the same, go in the same direction? If
yes, both.
Then the magnetic line of force and dielectric line of force have become one. I think that's what you mean by coherent.
Indeed. The coherent, they are basically moving together in the same direction.
Yeah, I usually think of it in terms of phase, but you're thinking of it in terms of position.
Position and time.
Yeah. Well, yeah,
so
then
both,
phase too. Yeah.
Yes, correct. So they are both coherent, both in time and in space. Then there is only a single conductor.
Yeah, that makes sense. But it's all theory.
Oh, well, we are exploring. Eric, we have to explore these conjectures, huh?
Well, at any rate, somebody has to make it work.
I agree. And that's
about
why
theory. That's me.
Well, Well,
Yeah, there
I
may be
mean,
more.
the fact that you demonstrated that this now at say for argument's sake 1,000 kilohertz, but that is an excellent demonstration for sure.
Yeah, I was flabbergasted. I mean, go, this is it,
I can imagine. I can imagine.
I mean, when I did the experiment, and I'm just, oh my God, I got to tell Aaron about this.
I'm sure. I'm sure.
There's going to be a video.
I'm looking forward, Eric, when we're back together next year around ESTC. We have a chance to share all these things again.
Okay. If I can make it, I don't know.
Oh, you'll make it. I have no doubt.
Yeah, I'm a little more concerned about driving thousands of miles anymore, but we'll see. Anything's possible.
We'll do our best to encourage you. Put it that way.
Well, that will be helpful.
Okay. Here, let's take a question from Paul. Go ahead and unmute yourself and say where you're from and go ahead and ask your question.
Hi, I'm Paul from Washington State, just a little neighbor to you guys. Eric, I've appreciated your work through the years. You're a giant in the field. Thank you very much. I believe in his notes with his lawyers, Tesla mentioned in his lawsuit with Marconi that the only people who really understood him were like Sommerfeld and Zenneck. And Zenneck described, I guess it's a transverse magnetic mode for surface wave propagation, but it's longitudinal in the electric mode. Is that right?
I'm not certain. Zenneck never really made it very clear, but he was employing, I believe, in his stations that he was building or building for other people, some type of wave that would not be considered electromagnetic in the
Right.
sense that we, think
Right.
of.
It was a waveguide mode. It was interfacial between a conductor and a dielectric, right?
Now, did you read that in Zenneck's book, or did somebody tell you that?
I didn't read that in Zenneck's book. There's Zenneck was written off by Norton in the 30s or the 40s. They did a Seneca Lake experiment and they used a monopole to see if there were surface modes excited, and they didn't find any because, I think some have said that because, a monopole doesn't couple well into that mode. And then they wrote it off, and they later said that Sommerfeld made a sign error in his calculations until 2004. I can't remember the name of the fellow. Some guy put out a paper that proves that Sommerfeld didn't make a sign error, but actually exciting the surface wave mode that Zenneck described has been rather elusive, and theoreticians have said like it would require an infinite length monopole to excite, and so that's impractical. But
Well, there's another theoretician that's actually less full of shit, and that's a guy named Gilliman. He kind of laid
yeah,
groundwork for, the Bell Labs guys and all that type of stuff. And he mentioned Sommerfeld. He was a student of Sommerfeld.
oh,
And he mentions him right in the beginning of his book, talking about propagation, that the surface wave distinctly exists, but the amount that it contributes to the overall flow of electricity and storage and all of that was relatively small. So from an engineering standpoint, that there was no point in getting into it, because his two
yeah.
books together are already about 1,200 pages of material that you could spend 15 years of your life studying. So,
Yeah, well, I mean, for any RF engineer looking at waveguides, they know well that you need to place your probes in the right place and excite the right number of probes for whatever mode you're trying to excite. So it's a little bit irrational to think that using the tools of the radio man is going to give you the effects of Tesla.
well, that's the whole thing. If you're using instruments that are designed for electromagnetism, then they're not going to work for what ain't electromagnetism.
Exactly.
So
I
Sommerfeld didn't get too deep into it, but he did make reference to Sommerfeld's own writings. But these guys usually buried everything so thick in mathematics. See, the thing
Yeah, right.
I learned because I'm in the process of writing textbooks right now. I complete one every 6 months. I have no way to get the stuff published, but I do it because I learn in the
Yeah,
process.
I've
And
gotten a
and
couple of your books on versor algebra. I thought they were fascinating.
and at any rate, the thing is I'm not writing the books to impress somebody how much I know, how many sheets of mathematics and all this kind of stuff, because that's what these guys do that write the textbook is they write textbooks for their peers, not to teach anybody or for anybody to learn. The only exception to that is Steinmetz. He
Yeah,
actually bent over backwards to make everything understandable. And that's why if you're going to get into the deep theory stuff, it's best to start with him. So basically,
right.
the Sommerfeld thing is it kind of exists part in the world of skin effect and part of in the world of surface charge, and it seems to occupy some radial dimension around the surface of the conductor, and that's all I can say that anybody really knows about.
Well, when I look at people trying in modern times to replicate Zenik on at least on a smaller scale, one of the more successful attempts seems to have been using vertical taper line segments, kind of the inverse of the bow tie that they use in ultra wideband, and then excite it with a traveling wave because the Zenik mode kind of has a backward pointing electric field. It looks a little bit skittywampus when you compare it to what they're used to in electromagnetism.
Well, the thing you're going to have to, in Zenek's time, you have to remember that everything operated between 10 kilocycles and 100 kilocycles.
Yeah,
And you're dealing with extremely high potentials and large quantities of dielectric energy storage, like under flat tops and what have you. That's basically what killed Marconi's system. Is the damn antenna was no more than a giant capacitor thing could kill you dead, not connected
yeah,
to anything if you touched it on the wrong day.
yeah.
That thing stored so much dielectric energy that it just choked itself. It couldn't do anything. So in an environment like that, where you got I forget how many wires it was. I did a whole analysis of the one in Bolinas. I think it was 32 conductors, which were like 4-aught bronze wire rope, 3,000 some odd feet long and 300 feet in the air and 600 feet wide, and another one underneath the ground. That was one hell of a capacitor.
Yeah, my suspicion with some of the difficulty some people have with exciting these surface propagating modes with Tesla coils, aside from the fact that they're not really building them with very much engineering forethought, is they excite it with like a zero voltage crossing sinusoid or something like that, and if you want to excite a mode that requires a Brewster angle to couple into, then you need something that a traveling wave that travels up your viewing your secondary, your extra coil as a waveguide rather than a part of a tank circuit with the earth.
Well,
I
that's
mean,
how it
Tesla,
operates. The Tesla transformer is not a transformer winding; it's a waveguide.
yeah,
But the thing is, I think I'll close on the Zenik thing with this. Tesla did
all right,
not seem to have the best opinion of Zenik, but I forget exactly. He mentions the guy in the patent thing because Zenik was the top theoretician at the time, and then in World War I, because he was a German spy, he got thrown in the brig, and Marconi was given the boot up the butt and sent flying back to England. So at any rate, that was kind of the end of his work here in the United States. But I would think, from as far as what Gilliman was saying, that this wave most likely attenuates so rapidly that it's probably not really useful for anything other than academic study, if you see what I mean.
yeah, I get you. I could get how Tesla might have used him as a prominent academic to back him. That makes sense. And
Yeah,
as far as the attenuation, so long as it's in the, the so-called near, kind of the approximate relation to the near field and the surface mode, the Zenek has an inverse R squared decay up to a certain point. But
I have Zenek's book here. Do you want me to pull it off the shelf and give you the title?
oh, I'd love that actually. Yeah.
Okay, hold on. RCA Semiconductor and Materials Library. Oh, it's even got its library card. Let's see, it was last checked out. Doesn't say. Must have been never checked out in its lifetime. And it gives Zenek is still alive. Jonathan Adolf Wilhelm Zenek.
But anyway, that wireless telegraphy, most likely if you go to archive.org, it's probably a free PDF already scanned in there that you can just download if anybody's interested in it.
It sure is. I found a link to it. I'll share it in the chat.
Okay.
Well, let's
Paul,
move on to another question.
Paul, I would just like to add what Eric shared, is that the Tesla transformer is basically a coherent and contained cavity. So it is a coherent cavity where both the electric and magnetic, the dielectric induction and the magnetic induction field are moving coherently together as one. That's why you could actually pass that through a single conductor. The only way that you can actually pass electric power through a single conductor is actually both of those induction fields are moving as one together. And the Tesla transformer is unique. I mean, that's what I enjoyed with what Eric was sharing before about the fact that he's now taking Tesla's work from 45 kilocycles to 1,000 kilocycles. Nobody's ever done that before. I mean, if they have, they haven't said. But that's a good demonstration to show that those induction fields are basically coherent together in the Tesla transformer, and that makes it very unique.
Yeah,
I just wanted
let me point out that with the waveguide and the Tesla coil, the normal pipe or hollow pipe or whatever type waveguide only has 3 energy storage coefficients, but the Tesla transformer has 4 energy storage coefficients. You have 2 inductances and you have 2 capacitances, so to speak, even though they're inverses of each other. But it might be better to say that what the Tesla transformer tries to do, which I don't think anybody's fully achieved yet, because it always splits into 2 modes of oscillation. One is anti-transmissive and the other one's transmissive. And so basically, it's better said that you have four elements, 2 in volts. One is the electrostatic potential, and the other one is the electromotive force, and they do not equal each other. They're in different dimensions. And then on the other side of the equation, then you have the conduction current, which we're used to, as the electron flow type of thing, which generates a magnetic field. And then there's also the displacement current, which may or may not generate a magnetic field, or it may be a magnetic field that we don't fully comprehend because none of this stuff's really worked out. So when all 4 of those are brought into balance, then the propagation on the coil becomes distortionless and it will oscillate at 1 frequency.
Mm-hmm.
And that can only be determined experimentally, even though I've developed the necessary mathematical equations to analyze that. The problem is there's no way to turn the physical dimensions into the constants of L and C and all those kinds of things. So basically it has to be done experimentally, and that is very painstaking, and then you have to wind a coil, then you got to wind another one with the same length of wire, go a little closer together. And you got to keep fooling around until you can get the scent of a trail and then follow it, and hopefully it'll lead you into what you want. And that requires like a whole team of people or somebody, that's as inspired enough, at an early age to begin the lifelong process.
So, Eric, in principle, if we follow along that whole the balance of those things in a Tesla transformer, in principle, could that coherence be extended over any distance?
You mean transmitted?
Correct.
Well,
Could
that's what we're doing.
Mm-hmm.
But right now it's what you call the series mode,
Mm-hmm.
which is that's the one that transmits. The one that you call
Yes.
parallel mode is anti-transmissive. So
Agreed.
now if the coil was distortionless, to fully understand this, you have to look at my video called Electrical Transmission of Multiple Coordinate Systems.
Mm-hmm.
It's only recommended for people that, have taken 3 or 4 years of mathematics in college, back maybe in the 30s or the 50s, not today because they don't teach anything anymore other than, where to riot, or I have no idea what any of it means anymore. But at any rate, I don't think anyone can understand that, but the basis for that is out of Gilliman's book, Communications Networks. And that's where he talks about Sommerfeld, with the whole 2 sentences, but he gives a footnote. All of these books are just filled with footnotes.
Mm-hmm.
So that gives the 4 constants: the mutual electric, dielectric, mutual magnetic, and the transverse magnetic, and the transverse dielectric, and at least gets it so you can start to turn it into some kind of physical model. One of which is the old open wire carrier lines where you had 4 cross arms with 10 conductors on each cross arm. Well, that's 40 conductors, and that is a transverse and longitudinal network. If you take 1 200-foot span, and calculate all those things, and that would lead to, an appropriately ordered differential equation, which would be impossible to solve.
But in principle, do you feel that it's possible, if you can maintain the balance between the dielectric induction field and the magnetic induction field in a coherent single inductor, that you could actually extend it over any distance?
I don't know until it's done. I mean, I'm interested in
Work in progress.
because it has other applications too, because most audio transformers and, and telephone signal transformers and anything that requires a wide bandwidth, they perform poorly. They jumble the phase at the band edges, and it's just, you can never get a proper frequency response, and they're real picky how they operate. And, but if you could get that balance, that would become a distortionless transformer, and then you could put, like a unit pulse in one end, and a unit pulse will come out of the other end with no oscillations or, any of that kind of stuff. But that's theoretical. It's theoretically can be demonstrated with equations, but to actually build it, you don't know how many millimeters this way and how much millimeters that way. It can't be solved.
Well, the reason I'm asking is because the implication of what you've seen with your car at 1,000 kilocycles is that actually what you received of the car was essentially that coherent mode between the transverse and the longitudinal at 1,000 kilocycles at actually quite a lot of distance.
Oh,
so
yeah,
it kind of implies, it supports that the fact that those 2 modes can be coherent together actually over very large distances.
Not really. All it does is say that, that if you use the Tesla mode rather than the Hertzian mode, for the lack of better words, then all of a sudden you're into a completely different form of propagation, which has to involve completely different coordinate systems and completely different dimensions. But as to how, I can't take it beyond that. But one thing that I would like to try I mean, I have no means to, but what's really fixated in my mind from the theoretical standpoint is to create a coil that has no distortion, or a transformer that has no distortion, and see how it behaves. And that I would imagine, considering that the so-called series mode is effective in transmitting, and that the other one, which is not effective in transmission, somehow there are two halves of something that want to come together.
Agreed.
Maybe the thing will cease to transmit at all. Maybe it'll become invisible.
I agree. I agree fully, because for me, that's the implication of a coherency between the two. I would conjecture that what you experience at the 1,000 kilocycles is basically the coherent mode between the two, as a conjecture. Otherwise, how do you pick it up? I mean, with Aaron's radio, he had no way of accessing that, because
No,
the
there
receiver
was no resonator, there was no waveguide. So
exactly, but there was no Tesla transformer that was able to take the coherent mode and actually convert it into something that you could actually use. Whereas that in your car, that was the case. You had a Tesla transformer, it was able to access the coherent mode, and as a result, you were able to receive what you received. That's what I would conjecture.
So basically, you're receiving in another dimension, or more properly, in another coordinate system.
Correct. It's a coherent mode. I agree.
Well, I'm not saying that it's coherent, but I'm just saying
to be.
what
Otherwise,
I
how
know.
can I mean the transversal
theory.
and longitudinal mode has to be coherent. Otherwise, how does it work?
Well, that's true. If they're going to occupy the same space, so to speak,
Yes.
then they've got to be one. But
yeah, I agree.
But it might be more complicated than that.
I'm sure the details. I'm sure the details are, but I mean, but the result nonetheless is significant.
I'm only going to say that I received, to make it in the vernacular, that I received radio waves out of another dimension.
Okay.
That's as far as I'll take it.
I'll treat that as a working hypothesis that maybe it's a coherent it's a coherent mode.
Well, it could be anything. Maybe it's Jesus. Who knows?
Well, that in itself would be coherent.
It still seems to be affected by the ionosphere, and other.
Agreed.
Right. All I know is that's the first step into building a communication system, maritime communication system, that actually involves this mode of propagation and does it quite effectively. That was the objective at the RCA transmitting station in Bolinas.
I agree. It's a very significant result.
Medium wave band on their frequency allocation of 426 kilocycles. It didn't quite go as planned. But that's a whole nother subject.
Irrespective, I feel it's a very.
We better let some more people ask questions, and we could go on like this forever.
So let me zip through a couple of these questions in the chat, and then let's talk about the telluric transmitter. So it's 1 o'clock now, and we've covered one video, so we'll be here till 6. I have time.
Might be a one video day.
Yeah, right.
I'm very happy, Aaron. Take all the time you need, huh?
Okay, let's see. Haka says, is asking, okay, so Eric, could you speculate on the propagation velocity of telluric transmission versus aerial atmospheric?
It doesn't have velocity.
Extraluminal would be the answer then, is your hypothesis?
Yeah, yes, let's just call it extraluminal. It's all worked out in that video. Electrical transmission of multiple coordinate systems. The whole theory's all worked out.
And make a
thanks, sir.
And make a distinction between superluminal and extraluminal. Because I see a lot of the comments and stuff.
Well, superluminal would mean faster than light. Mm-hmm. Extraluminal means that the propagation is not in the dimensions of velocity. Mm-hmm. So there's no reason why propagation has to be the dimension of velocity. That's just the way we look at it. So it's not in miles per hour, it's in per miles per hour.
Okay, let's see. Vinyasi, he's mentioning this John Sajeka use of so I don't know if did you know about the Yukaco machine, Eric? in like the Borderland days?
I don't remember that.
One of those radionic machines that, you know, you could put a picture of a crop in there and sprinkle.
Radionic is a whole different thing.
Yeah,
Radionic is basically an extension of numerology. And it's like 3 whole octaves out of what we're talking about right now. That's extra everything.
There, Eric, a discussion about numerology at some stage would be a good discussion
Yeah, that's
because that takes us to a whole nother level.
well, yeah, then you have to get into my Power of the Ether video.
Indeed, but I mean, after
Well,
all,
I
we
mean,
are
I'm just saying, you know, we can't talk about it now, but for anyone that wants to get into this stuff, the power of ether is related to music and electricity, gets into all the esoteric.
Indeed, but this is, after all, is where we are headed.
Well, it's not where I'm headed right now. I have a single-minded reptilian, you know, how would you say, fixation to build a radio communication system in the 400 kilocycle band for ship-to-shore operation using Tesla transmission system.
I'm definitely headed towards the esoteric. We can
Everything
compare
else
notes.
is excluded except for whatever the present textbook might involve, which right now is the complete theoretical and practical analysis of three-phase power, because everything has taken such a wrong turn. Somebody's going to have to write the book.
Agreed. Agreed.
That's what I'm doing. Right now, I know more about three-phase than any person does on the planet. But that doesn't
Agreed.
make me a genius or a giant or anything, because if you go back to the movie, what was it called? Idiocracy, which is kind of a documentary of our progress, is you have an army slacker who has a significantly below average intelligence, okay? But he gets sent forward in time where everybody's a completely useless idiot, and that makes him an absolute genius. So it's all relative. See, just because I know more about three-phase power than any other person on the planet can be construed that not a single person on the planet understands anything about three-phase power, and that might be more.
Probably because they haven't taught it in the last 50 years.
They don't teach anything anymore.
Well,
but that gives you a
now you're getting all these foreigners, they're doing this that they do in their own countries and making it a law here. It's surreal. It's a twilight zone. But let's get off that subject and stick to.
So I'll just tease you slightly, Eric. If you know the most about the three-phase power, then it's your responsibility to share what you know about the three-phase power.
Well, it's fine and dandy. I work on it every day, writing it, but there's not one person that's willing to pay for or to help get it published. So it's just strictly for my own personal entertainment. I mean,
no,
it's
that's not true.
With the
I'm glad you said that, Aaron.
music
Thank you.
roaring away behind me, you know, and my notes in front of me, and Bach's polyphase music and polyphase mathematics, and it's tell you, you know, I've been studying three-phase ever since my RCA days when I was in high school, and now I've got it all figured out.
I think you'll find Aaron's very keen to help you publish that because you're the only person that knows it.
My friend Walt had a saying, you know, when I built the station at Landers, that was his property. It was basically built for him. And I used to say, it all sounds great, but will I live to see it?
Agreed.
There's Earth signals streaming online right now.
Yeah.
Yeah, indeed.
Okay, so let's get into the I'm going to skip these other questions. This ionic currents and the Yukaku thing is too much of a detour. So the telluric, let's see, I'm going to do a screen share here, and I do have photographs. So instead of doing here, hold on a second, just give me a second here. Okay, so I'm going to do a screen share and do a little slideshow thing, kind of comment on some of these. Okay, share. Okay. Can you see that?
Yeah.
Eric? Okay. So these are the TCS radios that ultimately will be what's behind the telluric transmitter. For right now, it looks like this. except here, let me see, where's the picture of the beacon? It's in the video if anybody hasn't seen it. Just this right here was set up by Haka says. There's an issue with it right now, so I see there's a lot of interest.
Maybe we should step back and do a brief summary of this project, the whole telluric transmission project.
That's kind of what I want to do. So, but at any rate, it was pictured right now. None of that stuff ended up working, and it all had to be removed. So basically, we have to start all over again. And Connor and I are now rebuilding, or building the original system to use the Navy TCS, because unlike all this made in China crap and it doesn't cut the mustard for this type of stuff. It's not reliable, particularly anything that has software. This whole project was cursed from beginning to end by software issues. So software is going to be vigorously weeded out of every aspect of this project, starting with this. So basically, the TCS transmitter receiver combination was used in smaller naval, mostly landing and patrol vessels in World War II. And it's a transmitter that you can put on the air and walk away from it for 10 years, and you can come back and it'll still be working. And that's the way things have to be. And there's a companion receiver that goes with it. We can't receive here because of extreme severe gangrene energy radiating out of some Chinese Trojan horse in a nearby gas station that is pumping probably several kilowatt radar pulses at 180 pulses per second back into the power system in town and causing the whole thing to light up. But of course, because nobody can pick it up on their silly phone, they says it doesn't exist. But and then, of course, the power company and the tradition of all utilities in the country right now have bypassed the transformers and have connected the high voltage neutral to our neutral, which is bonded to the metal side of the building. So all these things have created a giant spark gap transmitter. So all we can do is transmit. We can't receive. But FCC rules and regulations specify that when you have a transmitter on the air, you must also have a receiver capable of ascertaining your frequency and monitoring the signal. So that receiver is required by law, and it will be used basically for the FCC requirements of listening to the signal, particularly if you're sending Morse code by hand. It's very difficult to send on a key without being able to hear your own signal. So these radios have just been modified for this class of service. They've been modified in such a way that their basic historical and original purpose has not been altered. There was just things that were funky from the beginning. They're not really, we need 100 watts, and they were only, the power supply driving these will only put out 40 watts. I tested these when I was in high school to 200 watts, which of course is only temporary. Vacuum tubes are rated for 100 watts. And so this is going to be upgraded to that. We'll start off with the 40 watts and then work our way up from there as other power supplies and what have you. So presently, I don't know if Connor is in or if he has any of the pictures, but we have just completed the isolated 120 volt power system that is separated from the power company neutral. And the next thing to do is to put in the 12 volt power system, which will run the dynamotors for this or run the other radio that you saw in the picture that the software decided to play games with us. But nevertheless, those type of radios are convenient sometimes in the initial tuning process. So there'll be an outlet for it and an outlet for this, and it will have a rectifier, a battery charger, and the 12 volt battery and everything to create a very reliable, powerful, and stable 12 volt power source. And then once this thing goes on the air, other than maybe a frequency adjustment now and then, can simply be left alone and don't have to worry about any software, don't have to worry about China, worry about any of those things at all, because this is good old American-made World War II radio equipment that was built the last 3 generations without causing anybody problems, and that's why they're still around. So that's kind of what these relate to. So if you can go back to the outside.
Let's see, this shows the scale pretty good here. So the idea is that the beacon is basically going to be transmitting Morse code with your call letters, basically just saying this is your call letters, and then it repeats, takes a pause, repeats. And so the idea is that anybody who's into radios can tune into the 1.999 megacycle and see how far away that they can pick up that beacon and like report it back to us. So it's all, it's experimental, but it's something that people can get involved with to experiment with this. And what was it, a year ago, sometime last year or whatever, for under 5 watts, it was picked up about 125 miles away, something like that. And
Yeah, it was sporadic, and it only happened one night. But when we were working with Steve McGreevy, he was able to pick it up with less than 5 watts one evening. I believe he said it was 130, 135 miles away in Keeler.
okay. And I do want to add something is that it's possible that the distance that you can pick this up grows over time. We saw this with John Bedini's ground radio system, which was kind of based on kind of along the lines of some of the stuff that Stubblefield was working on. And Peter was with him where John had a transmitter, I think, near his shop. And then they went, miles away with a receiver. And wherever they stuck a ground rod, whether it was, through the bark into the tree, in a river, on a rock, everywhere that they touched with that ground rod, it picked it up. But what they noticed was over time, little by little by little, they could pick it up further and further and further, almost like something through the ground was polarizing or something. And where the transmitter was, all the weeds were growing so strong, they were like miniature little trees and bushes and stuff. Like this happened right there in Post Falls at one of John's shops. And so for sure, over time, at least that particular method, which I don't know how it's, what the difference would be. That was back in about 2004 when Peter Lindemann was working with John for about a year on the battery charger stuff. And that's when those experiments were going on. But absolutely beyond a shadow of a doubt, over time, it grew where the distance they could pick it up went further and further and further. So who knows? The same thing might happen with this. It's an unknown, but that's something that I would expect to see. But I just want to throw that in because that hasn't really been mentioned, but that's a possibility.
Aaron,
But
I would just,
Jerry
I would,
Vassilatos talks about that, and he
Okay.
calls it the vril. It's something that grows with time around the old, Alexanderson and Marconi and all those old radio systems. It tracks these kinds of dendrite formations or what have you. That sounds like what's going on with what you described. Now, I don't know whether this will do it or not, but when the thing finally gets on the air, we'll determine that. But there's a lot of work to do before this thing can get back on the air again. We had it fired up pretty good, and but then it's very difficult to fine tune these things. So we came up with I don't know if you can get a bigger image of that or not. If you could, I could kind of describe what's going on here. Yeah, that's better. Can you get just
Aaron,
that?
I would just add, Eric, if I could just add, Aaron, I would also add that the degree of coherency over time also grows. So when something starts as coherent, in other words, when it is in phase both in time and space, then that coherency extends. It extends both in time and space. So something becomes more coherent over time. So I would support. I would support what you're sharing. Sorry, Eric?
Yeah, there we go. You got it bigger. Yeah. So this is the aerial part. So basically, this is the aerial capacitance. To adjust the frequency of the coil, you have to have a variable capacitor between the aerial capacitance and the high side of the coil winding. That's being blocked out right now. Okay, so see, this thing has to be able to operate out in the weather, and that is almost an impossible situation, because when the poles get wet, these poles are as old as me, and they soak up a lot of rain, and when they do that, then that alters the whole, dissipation constant of the dielectric field, and it increases the capacitance and pulls the frequency off, and the insulators get wet. And this is kind of, it's hard to have this as an experimental, this is a test platform, but to leave the stuff there, and it's not going to work when it's piled in snow. These are some of the things we're up against right now. So that thick piece in the aerial is one way to get a small amount of capacitance with a high voltage rating, is to take a section of transmitting coaxial cable. This is actually very low attenuation cable TV entrance cable, but it's good for about 10,000 volts, not because it had to, but because losses had to be minimized. So what you do is you take the outside shield and you connect that to the aerial, and you take the center conductor and connect that to the transformer coil, and then you have to start peeling off the shield around the coax until you can find the spot in which it resonates. And
very specific picofarad.
Yeah, this thing is like really sensitive, and if you're standing there, your body's completely short-circuited the thing. And we got it on. What actually needed to be done, I didn't think about this in the beginning, but what needed to be done is, unfortunately, because you can't tune the coil to the transmitter, you have to tune the transmitter to the coil. But because of the software complication in the keyer, we could not change the frequency. Otherwise, we'd be transmitting, we're on one frequency, and we'd actually be transmitting on another. So we couldn't do that. And then the rain and what have you, caused a complication. And the one thing that screwed everything up was, it's not in this picture, is there has to be like a little open wire transmission line on insulators on one of the poles to connect to the voltmeter inside, so that you know how well your coil's resonating. Kind of doing the same thing the field strength meter or the fluorescent lamp does.
Kind of like tuning.
Yeah, so this thing was so sensitive that just putting that up knocked it off frequency. And then the invariable, when you're dealing with these kind of situations with, sporadic people showing up and volunteers and all that, is, unfortunately, everybody runs away before the project's finished. So the whole thing is out of tune. And at that point, it was best just to start fresh again. So right now, the main complication is getting the TCS going is not going to be a complication. It's a matter of procedure. Matching the TCSs to the 50 ohm coaxial transmission line going to this platform, that will be next. That's not a particularly big deal. And then what's more difficult then is going from that 50 ohm line to the input impedance of this coil, which the transformer that's there now does seem to be effective. We've gotten some amazing distance with the fluorescent lights around this thing with very little power. So basically, another tune circuit might go there to probably will to optimize on that and get that thing all tuned up. And so right now, everything out there is soaking wet. And nobody's here to help with the other part of it and what have you. So this is all kind of on standby now. But at any rate, the experiments that have been done with this, both by making potential measurements between ground electrodes and driving off with the PRC 47 in my car with only an 8-foot CB whip, where we're talking about wavelengths here of 160 meters, and picking this thing up loud and clear, like 50 miles away. And it's definitely, even though the frequency is considered to be way beyond what you would use for this type of stuff, megacycles, it does seem to be quite effective. And so once all these things are conquered and done, and weather dries out again, then this will go on the air full time. So that's
So
kind of where it's at now.
So Eric, a question. I mean, with this 2000 kilocycle system, a telluric system, can this produce the same kind of result as you received at 1000 kilocycles with your car? Is it essentially the same principle?
Yeah, same thing.
It's the same principle.
Yeah, it can transmit and it can receive, but the problem is I can't receive because of the gangrene energy is so severe. And there's no way you can do anything about that. I mean, at some point, I can try to tell the power company, that some made in China motor controller in the gas station is shorting out the power line in 1 microsecond intervals and lighting the whole town up. That might pick up the ears of the district engineer. I've already got a reputation with her for the one that was figured out why the primary fuses were blowing in the substation and leaving the town without power for 12 hours. I think that made an impression. So, but at any rate, there's all these political currents that go along with this kind of thing. And it's now not the time to do that now because we're negotiating with them to get the power hook back up in the mine. And it's not a good time to spread out into other topics, particularly controversial ones. There in that picture, you can see the sense line on the side of the pole. It's a little closed
right here.
wire.
Yep.
Yeah.
So we had that tuned to 1999 almost exactly. It took about a whole day. And then making that little modification, that little tiny wire on the right, brought it from 1999 to 1983, like way, way off. And
knocked the whole thing out of kilter.
Unforeseen consequences.
And then the thing that really aggravates me is then everybody leaves.
So can't we?
I got to recoup my funding.
Can't we put some type of cheap cover on it, like some corrugated plastic, like that cheap stuff that covers patios and stuff?
No, we just have to retune the capacitor, but it was kind of late in the game.
Anything around it is going to make capacitance. And the other thing is, I have a reputation here, and I can't have a bunch of crap together stuff and cockeyed, something that looks like it was you find in a barrio in the Philippines.
Well, just because it's cheap doesn't mean it has to look crappy. I'm just saying
normally what you would do to see the problem is you have to have a insulator bushing on the top to connect to the coil. So how do you lower this thing onto the coil? It needs a radome is what it needs. Now, the other thing is to build a little octagonal pagoda out of, like Lexan and make a little, 8-segment roof to at least keep the snow and rain off the thing. This coil it's gooped up pretty good to work outside, but I just don't want to leave it outside not doing anything. So I'm probably going to take it back inside. I mean, it's not Navy style yet. If this was Navy style, the verticals on this would not be, lacquered wood. They would be ceramic, just like they were out at RCA.
Well, and, Eric, here's an idea. You could basically have a top load that was a small construction of Wardenclyffe Tower. You could have a dome, an electromagnetically active dome over the top.
Scale model Wardenclyffe.
I'm thinking in the terms of a pagoda type structure where you would have 8 vertical rods, and then you would have some kind of lapped joint arrangement or something with the segments on the top, so you could have a watertight roof, and then you would have like a transformer bushing coming out of the top.
Mm-hmm.
You could even start with a flat piece.
Better to have a dome structure.
Well, who's going to make it?
Yeah, that's a
electric property is going to be.
That's a good question.
What's going to hold it up? So what I'm going to do about the tuning capacitor is the coax thing's too difficult, and then you got to tape it all up and make sure the water doesn't get in and all that. But I'm going to go back to what I do is I use a strain insulator as a capacitor. So all insulators are capacitors. So what I have to do is I have to find a point on that vertical conductor where I can place that strain insulator in there, and that divides the capacitances. And then then what I can do is I can make like a dielectric ring on either side of the insulator and then bend the wire up and down to get the thing fine tuned. That's still, it's still not what I want. But see, this thing has got to be able to be out in storms. It can't be flimsy or what have you. It's got to be rigid. It's got to be unaffected by moisture. There's no way this thing's going to ever work in the pouring rain, whether it's got a cover or not, because just all the raindrops, the wet pulls, the wet insulators, it's just kind of that would have to be, when the Navy says they want one.
Do you feel there's a more stable way in order to establish the balance for the telluric reception?
Well, one way is to have an adjustable corona ring, equalizing ring on the end, on top of the one that's already there, and raise it up and down. That would be, that's one possibility. But the thing is right now, I think that wouldn't work too good, because there seems to be some element necessary in this system that's away from the transformer. And that's the T structure that the poles are holding up.
Now, can't the poles be painted with like a primer that waterproofs them? So
No, they're too far gone. They'd have to be replaced with new poles. I mean, you can buy them, I guess, but
yeah, but I mean, if they're painted, then obviously they can't soak up water.
those poles they're corrugated. They've got cracks in them that go in. I mean, it's not going to work.
Yeah, but just say if there are new poles, then they could be waterproofed.
Well, they're already. If you get your standard, fuel oil creosote type dip poles, I mean, those cross arms and stuff, I mean, they're like plastic. That wood just becomes completely plasticized, and that would keep the water out.
But I mean,
So
if we put
basically, that's the problem, is the impedance is so high on these things. Now, the other thing, of course, it's a telescoping vertical and all that. But the thing is, this is a test platform. I don't want to get too caught up in, in one thing, because there's actually another coil supposed to go here, but no one's been able to make one yet that's suitable for outdoor use or create other complications. So that coil didn't work out. That's the Alexanderson coil. But because that thing has so much inductance, it's probably going to be even higher impedance. This thing needs to go down to 450 kilocycles. And I think a lot of this stuff will be easier to deal with. But it's still, in the long run, it's just going to be really sensitive. Now, another way to tune the coil is a tunable inductance, a variable inductance in the current lead of the coil. That has the same effect as putting a capacitance in the top of the coil. It wouldn't have a lot of inductance. It would probably be a single turn with a shorting disc in the middle that you rotate like a variometer. That's the way that RCA used to do it in these big 50 kilowatt transmitters.
But that's going to break the low impedance connections to the earth.
Well, let's see. I mean, the thing is that inductance is absorbed into the inductance of the coil. Just so.
Well, it's discrete though. It's not part of the.
Well,
it's not part of the overall structure of the coil, though.
Yeah, but neither is the capacitor.
True.
So there might be, a certain balance if you got the same amount of energy on one side as you do on the other in two different fields. So there's a lot more work needs to be done here.
Agreed.
Should we take some questions? If anybody has any questions on this telluric video, go ahead and raise your hand or type it in the chat and I'll read it. So if you have any questions, then so instead of a Q&A, it's just going to be an A.
I will say it was interesting with the video out, because there was a lot of people, a lot of hams and amateur radio people trying to listen into 1999 to see if they could pick it up all around the country and the planet. It was a cool community effect.
And nobody notified me that it was not on the air or in the ground when I put out the video. So I put it out and saw the response. But one thing I would like to do is on epdlabs.org, just like there's that seismic earth signal link, is to have some type of status indicator for whether or not the beacon is on the air or not, you know.
Yeah.
Well, there was one good thing. There's one good thing that came out of that. And actually, in a certain sense, it's kind of good that people keep listening there, because if we're going to go on that frequency semi-permanently, we need to know what else is going on that frequency until we get our own FCC allocation. So it was not, even though it was an embarrassment, it was not a totally wasted effort on the part of the people trying to receive, because people were picking things up. And so that kind of gives you a feel. The only complication is most people are using, you know, this software-defined radio and all this other digital gobbledygook, like the radio in your truck and what have you, that couldn't possibly pick this stuff up. So unless you actually have your own Tesla transformer or Rogers antenna or something that, you know, is actually a telluric-based antenna system, you really shouldn't be relying upon these so-called monitoring stations as verification, because they are strictly electromagnetic and they might not be particularly well designed. There's a lot of little details with antennas that these people don't understand. They think because signal comes in, you know, loud and clear, and they hear 4 or 5 stations booming away, there might be a station 30 degrees off bearing from that you could have a 1,000,000-watt transmitter and they couldn't pick it up as a faint beep because of antenna patterns and all that type of stuff. So the other end has to kind of try to receive in the same mode one way or another in order to be totally verified. But I have done this in Bolinas on 7 megacycles. Our frequency there was 7037. That was established by the RCA station there in Bolinas, where all the KPH operators would get together in the ham bands. And I had no problem. I had a booming signal coming in to Los Angeles from Bolinas, which is north of San Francisco. And the ham I was talking to refused to believe that I had no antenna, but his arrangement was such that he had a big loading coil on a short antenna, and that was close enough. So it's all open to experimentation, and this thing will get back on the air. It's going to be a long, arduous effort, but when it gets done, I can just close the switch and walk away from it, and it will continue to operate without any complications. We're going to go back to the Aaron has already started to design the old code wheel for making the Morse code message, like used to be done in the Navy in World War II for beacons. Is they had a little disc with the cam and had little slots cut in it, and a little micro switch would go in and out of the slots, and it'd send the call letters and the message over and over again. No software, no China, no silicon semiconductors, no microchips, just a simple clock motor and a cam and a switch, with a lifetime of probably around 50 years. So that's the way everything's going to be done here from now on. No more software.
Eric, a question. If we can just go back to the telluric platform, what we were discussing. So if the impedance at the top is a problem from the capacitive load, and the inductive impedance at the bottom is also a problem in terms of its low impedance to the ground,
Yeah,
where do we find the balance? Where do we find the balance point for that coil?
well, if you're going to load it at one end dielectrically, you have to load it magnetically at the other end with the same amount of energy storage.
Agreed. But if we want to get that Tesla transformer so it's in the ultimate coherent mode, where do we define that balance?
That's undefined.
You mean it's basically work in progress. It's an unknown, a work in progress.
It's all got to be experimental. So just because the equations are all worked out, the thing is you can't put the figures in the equations because there's no way to determine them from the measurements.
I agree. That's also my experience.
Experimented, and there's a possibility with some of the old, I have one of the old wireless books. It's called National Bureau of Standards Circular 74. It has all the old wireless equations. And
Uh-huh.
that thing is priceless for doing this kind of stuff. So
Uh-huh.
it's got the equations for mutual inductance and self-inductance and multi-wire aerials, and that thing is absolutely priceless for this.
Uh-huh.
If you got to be careful, nowadays you go on the internet and thinking, you're going to find this stuff, but you got to watch out because sometimes that stuff's not right.
Of course. But do you feel that this is something that was known in the past, which we're now rediscovering, or we rediscovering this for new?
Well, I think a lot of this was known by the Zenit crowd, and all of them. Goldsmith and Zenit and Fessenden. The whole the post Tesla. Once Tesla took the bite in 1905, this whole second wave came. Up until Marconi pissed the Navy off, and then everything got kind of shut down when the war started.
Can you just speak, when you say the second wave, can you just speak to what the first wave was?
That would be Tesla, Steinmetz, Alexanderson, whoever were, the people that first started off in all of this. Namely Tesla. Tesla was really the only one in the beginning.
So if they understood what this balance point was, what I call coherence, why do you feel that they didn't write that down or express it or experience it?
Because Tesla was he's a typical stuck-up European, okay, with his nose up in the ionosphere. And the thing is, what happened when I took the bite, when I lost RCA and Commonweal smashed all the equipment, what have you, and my friend Philo Farnsworth said, okay, well, the only thing you can do now is write books. That's what Tesla should have done. And he didn't. He remained stuck up. He remained, possessive with his inventions or what have you. And the sensible thing for him to do would be to start writing books. That would have ultimately defeated all of his enemies. Particularly if he did it in the manner of Steinmetz and didn't try to make it overly romantic or overly complicated.
I agree with you, for sure.
So consequently, everything he did just swirled down the bowl. And it was the same thing with Farnsworth Sr., the master of the electron. Philo's father.
But then this challenge.
Same thing. Took the bite, okay, and got jammed really good, real good. And then the whole family goes into a sneer and a pout and hisses at the world outside, and nobody writes it down. So now all of that information, all of that genius of Farnsworth and his knowledge of the electron, which is, would make J.J. Thomson stand up in his grave.
But then what it means is that challenge now transfers to us in terms of rediscovering that.
Yeah, but we don't have, remember, Tesla had $1 million to screw around with, which is what, $100 million now? Well, if I had $100 million, I might be able to make some progress. But the thing is.
But you did make some progress. But hang on a second. Let me just interject. You took 45 kilocycles from Tesla to 1,000 kilocycles with the Tesla transformer in your car. That's actually quite a big step forward, actually. Don't you think?
No, it's a step that was basically already there. But the thing is being able to calculate a distortionless oscillating transformer. Well, that's a lot of experimentation.
Oh, of course, it's going to need a lot of work.
Yeah,
but it's a good step, though, Eric. It's a very good step.
And what have you? I'm kind of out of commission, so I have to direct other people what to do. But the problem is there's nobody that can do anything anymore.
Well, you've got Aaron.
Well, Aaron's got his own business to take care of.
But hey, Eric, on your private page, I did post, I don't know if you read it, but I did post something about the perfect transformer and the.
Yeah, I saw that. I saw that. Yeah.
So we can continue that conversation later just to see what.
Yeah, we've already covered that enough. I think actually the next thing now would probably be the Earth signals. If there's no more, doesn't seem to be any questions on this one. I guess it's too theoretical for people.